Hello, beautiful people, and welcome. In today's video, we are going through the Chapter 3, Are You Ready? This is going to be a part 1 for your part 1 of the exam. As always, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I may learn from my mistakes. Let's go ahead and get started. Question number 1 is asking you to add and subtract. Notice that you do have subtracting here. Anytime you have a subtraction, you do need to distribute that minus. You're going to rewrite this as adding negatives, which means you're going to be switching the sign to the opposite you see. Now we're going to keep this first bubble, this first polynomial the same. We're not changing this one. And the reason we're not changing this one is because it doesn't have a minus or a negative in front of the parentheses. So here we're going to do opposite of what we see. So and a negative 1 plus 5b squared minus b to the fourth. And so we're changing these minuses to ands. A negative 6b, a negative 6, a positive 4b cubed, and a negative 7b squared. Now here you have a choice. You can either rearrange them or you can line them up to do combining like terms. Usually what I do is I kind of go in order and I cross things out, combining them as I go. So for example, I have 8b, so I'm going to cross out 8b. I have 6b squared. I'm going to write it a little bit lower because it is a different, unlike term. I have a 4, which is just a constant. I have a negative 3b to the fourth. Again, writing it in its own lane just because it is different. I do have a negative 1. I'm going to pair that with a 4. I have a positive 5b squared. I'm going to pair that with the b squares. I have a negative b to the fourth. I have a negative 6b that's going to go with 8. I have a negative 6. I have a 4b cubed. Notice I don't have a b cubed yet, so I'm going to have to write it on its own. And I have a negative 7b squared. I'm then going to evaluate, simplify each row. Now this is not my answer. This is part of my work for my answer. So I'm going to pick up a calculator, and if it has a variable b, then it's going to stay. So what I mean by that is here we have a row b, here we have a row b squared, here I have a constant, here I have b to the fourth, here I have b cubed. So those variables are going to stay there. Now I'm just going to type into my calculator what I see. So 6 plus 5 minus 7. I have 4 minus 1 minus 6. Negative 3 minus 1. Don't forget that 1 here. And we just have 4b cubed. Now again, this is my work. This is not my answer. So I need to rearrange this in standard form. If it's not in standard form, it is going to be marked as incorrect. Okay, so format does matter. And I'm looking for my highest exponent. My highest exponent is to the fourth power. Then I have to the third power. Then I have to the second power. Then I have just b and my constant of negative 3. This is my answer. Okay, moving on to question B. Again, it is still asking us to add and subtract. Notice I have addition here and subtraction here. So I'm going to distribute on x, on negative 4, on negative 5, and on negative 7. Now this adding this plus that we have, we're not going to change that because distributing a positive won't change anything. So the 7x cubed minus 4x squared minus 6x plus 6, that stays the same, plus 6 minus 5x squared minus 3x cubed, that's also going to stay. But what's going to change is this x, so we're going to say and, that's just in English, and negative x plus 4x cubed plus 5 plus 7x squared. We're going to do exactly the same method as before in Part 1, I am going to hopefully in this video start skipping a little bit with similar questions just to make these videos a little bit shorter. So again, we're going to line them up. So here's 7x cubed. That goes away. Negative 4x squared. That's gone. Minus 6x plus 6. I have another 6. Minus 5x squared. Minus 3x cubed. Then I have a negative x, a positive 4x cubed, a 5, and a 7x squared positive. If it has a variable, it's going to keep that variable. So x cubed stays, x squared stays, x stays, and then constant doesn't have anything. We're going to pick up that calculator. We're going to type things in. So 7 minus 3 plus 4 is 8. Negative 4 minus 5 plus 7 is negative 2. Negative 6 minus 1. Be careful with this one. Get negative 7. 6 plus 6 plus 5. I get 17. Again, that is just our work. That's not our answer. So we need to rewrite this as standard form polynomial. So 8x cubed minus 2x squared minus 7x plus 17. Now this is just an expression, so you do not need to set this equal to 0 or set this equal to p of x, f of x. This is just simplifying expressions, so no equals here. Here it is asking us to multiply, find the product. Now you have a choice here. You can use the distributive property and distribute everything. Sometimes that's called FOIL. I would prefer you not do that. If it's more than a binomial times a binomial, go ahead and use a box method to organize your thoughts. Anything greater than 2 things in a parentheses, then I encourage you to use box method. We're going to write things out. So we got a negative 4m squared minus 4m plus 8. Here we got negative 4m squared minus 5m plus 8. I'm going to write these pluses on the 8s just so I don't forget. And here's how it goes. It goes number with number, letter with letter. So numbers get multiplied together. Exponents, the letters, need to be added. So we have negative 4 times negative 4. And here we got m squared times m squared. So those 2's are going to be added. So inside of the first bubble, I'm just going to do this once. We get a positive 16 m to the 4th power. 4 times 4 is 16. Negative, negative is positive. Here I'm going to add 2 plus 1. That's 3. Here we got 8 times negative 4, which is a negative 32. M squared. Here we have negative, negative, positive 20m. Add 2 plus 1. Here we have a positive 20m. Add 1 plus 1. And here we have 8 times 5, which is 40. 1m. Here we have 8 times 4, which is 32 with a negative here, m squared. Here we have negative 32, just m. And here we have 8 times 8, which is 64, positive. Again, this is not your answer. This is just your work. So with that, we have to combine things. So if we see things with the same variable and exponent, we're going to add these together. So we have m cubed and m cubed. We need to add. We have lots of m squares we need to add. We also have m's that we need to add. And then we can write out our answer. So for our answer, we have 16m to the 4th power. And again, yes, this needs to be in standard form. So decreasing exponential power. 20 plus 16, I get 36 m cubed. We get negative 32 plus 20, negative 32. I get a negative 44 m squared. Negative 32 plus 40, I get 8 m. Oh, I almost made a mistake. You guys see that? This should be negative. Let me go ahead and highlight that for you so that 8 is incorrect. Should be negative here. So that's going to change it. So we have negative 32 minus 40, which gives me a negative 72, not m, not 8. There you go. And then we have plus 64. You don't need an equals on this. This is an expression. You're going to do the same thing for B. I am going to skip a little bit. Remember, number with number, letter with letter. I am just going to write out the answer on this one. So this one's going to end up being 36x squared minus 9y squared. Now in standard form, because we are given two variables, you have to kind of pick one, which one you're going to be writing first, and that has to be in decreasing exponential power. Okay, so since x is given to us first, that's why x is first. Now this one here, I do want to expand before we write things out. So what I mean by that is because you have an exponent of 2 on the outside, not the 4 that you see on the inside, but the exponent of 2 on the outside, you're going to write this out twice. Negative 8x plus 7y to the fourth times negative 8x plus 7y to the fourth. Then you are going to proceed to multiply using box method. And remember, you're going to add, subtract the like terms afterwards. So let's go ahead and do this one real quick. Negative 8x, 7y to the fourth, negative 8x, positive 7y to the fourth. Number with number, letter with letter. If there are exponents missing, we can put those in. So 8 times 8 is 64. Negative, negative, positive. 1 plus 1 is 2. Here you have to be careful because we cannot add the exponents with terms that are unlike. So what I mean by that is x and y are different letters. Therefore, we cannot add their exponents. So we have 7 times negative 8, which is a negative 56, which then means I have x to the first power, y to the fourth power. These are unlike things, so we're just going to write them next to each other. Again, I get a negative 56 here. I get x to the first power, y to the fourth power. 7 times 7, both positive, is 49. This one are like terms, so I can add 4 plus 4, which gives me an 8. Be careful here because, yes, we cannot combine the exponents, but these here are still like terms, and we can still add. The reason they are like terms is because both of them contain x to the first power, y to the fourth power. And because those are the same, we can put them together. So for our answer, we got 64x squared, negative 56 minus 56, or you can add, is negative 112, x to the first power, y to the fourth power, plus 49, y to the eighth power. Okay, moving on to the next one. Find the quotient. It's going to ask you to divide. Now, it is your task to know when you are allowed to use synthetic division and when you are allowed to use long division. Now, remember, long division is always going to work. Synthetic division sometimes works as long as we meet the requirements. First thing you're going to do is you're going to check for standard form. You are unable to do long division if anything's missing or if it's not in decreasing exponential power. So the first check is I'm looking at the exponents. 4, the next one should be 3, and it's not. I'm also noticing a 5 is here. And then you can take a look at this binomial, which also is not in order. So we're going to rearrange this. I'm going to start with my highest exponent, which is 5. Then I need a 4. Then I need a 3. And I'm looking at my exponents. Then I need a 2. Then I need a 1. And if something's missing, you're going to put a placeholder of 0. Then I need a constant. Okay, so that's in standard form. Then this one here needs x to be first. So we got 7x minus 1. Be careful with that 1. It is negative. So again, what are we looking for standard form? We are looking for exponential decrease. So 5, 4, 3, 2, secret 1, and then secret 0. That's what we're looking for. Notice here that this is, although linear, you do see a value. That means you don't have a coefficient of 1. Because you see a 7, you're going to do long division. If it was missing a coefficient, if that 7 was not there, then yes, you can do synthetic. So this is long division. We're going to go ahead and write out our typical long division bar. Here we are writing 7x minus 1, and here we have 7x to the 5th minus 43x to the 4th minus 36x cubed minus 29x squared minus 44x plus 9. And what you're going to do is you're going to start off with the inside term, leading term, so 7x to the 5th power, and you're always going to divide by your divisor leading term. So I'm going to color code that for you. Oops, should be an X. You get rid of this marker. And what this does is we're going to divide number with number, and we're going to subtract our exponents. So we have 1 here, then 5 minus 1 is 4. This x to the 4th power, we're going to write on top of the x to the 4th powers. I'm going to then multiply by my divisor. So I'm going to bring in 7x minus 1, distribute that. So we have 7, remember adding the exponent, x to the 5th power minus x to the 4th power. I'm going to copy that down. Now you know you're doing a good job, a correct step if your leading coefficients here, your 7s and your exponents, if they match up. If your leading terms don't match up, that means something went wrong. Now this step is very important. You're going to be changing the symbol. So if this right here, the 7x to the 5th power is positive, make it negative. And this one's negative, we're going to make it positive. Now we're just going to add. And again, if you've done the steps correctly, this will be removed. Now here we're just adding negative 43 plus 1. I get a negative 42 x to the 4th power. We're going to bring down the negative 36 x cubed, and we're going to continue the step. But now instead of using 7x to the 5th power, this blue 7x to the 5th power, I'm going to be using my new leading term, which is negative 42x to the 4th power. Still using my divisor of 7x. Number with number, letter with letter. That means I get negative 42 divided by 7, which is a negative 6. 4 minus 1, we're subtracting. We get x cubed. I'm going to write my x cubed here on top, so minus 6x cubed. This negative 6x cubed goes on the bottom as well, and we're going to multiply 7x minus 1 by it by distributing. So we get negative 42x to the 4th power minus plus negative negative is a positive 6x cubed, which is kind of running out of space. That's okay. So we get negative 42x to the 4th power plus 6x cubed. Again, we got to go in and change the symbols. So that one's becoming a plus, that one's becoming a minus. When you add, these should be removed. We got negative 36 and a negative 6. I get negative 42 again. Bring down the next term of negative 29x squared. We're going to continue this pattern until we get our answer. So then we have once again, we take that negative 42x cubed We're going to be dividing it by 7x. We get a negative 6x squared. So we're going to write in that negative 6x squared. Multiplying it by 7x minus 1. So similarly as before, negative 42x cubed plus 6x squared. And again, we need to go in and change our sign. So that becomes a positive, that becomes a negative. So here we are removing our 42s. Here we are adding. So we have negative 35x squared. Bring down the next term. Doing our steps again, now with negative 35. Negative 35 divided by 7 is a negative 5. 2 minus 1 is just 1. Let me write in my negative 5x so I don't forget. Multiply again, don't forget to add your exponents. Change your symbols, make sure you do that. And I recommend you doing this a little extra. Do the scribbles, otherwise you're going to change it and then accidentally change it back, like multiple times. Don't do that. That's gone. Negative 44 and, so plus negative 5. We get a negative 49. Bring down our next term. And we're doing that one more time. So we get negative 49x. And then we get positive 7. Again, go back and change your signs. That's going to remove. We get 9 and, so 9 plus a negative 7, which is 2. Since I have nothing more to bring down, that means we are done. Okay, but this is not our answer. We have to actually write our answer. Our answer here is taking that x to the 4th power minus 6x cubed minus 6x squared minus 5x minus 7. So all of that came from here. And then since we did have a remainder, we're going to pick up that remainder, this 2. And we're going to say and, like in English and, with an addition symbol. Then whatever your remainder is, positive, negative, you're going to place that in your numerator. And then your denominator is going to be your divisor. So you're going to pick up this denominator of 7x minus 1. Now, if this can simplify, if this fraction can simplify and you can pull out a GCF from this fraction, you have to simplify your fraction. But 2 and 7, they don't get along, so we cannot simplify. That is it. That is your answer. Okay, so how do you know if something is, this is not something they're asking you, but I do want to ask you, how do you know if something is a factor or if it's not a factor? Because you see a remainder, that means negative 1 plus 7x is not a factor because it has a remainder when dividing. And you can say instead of 8/2, it gives you a remainder when dividing. This one here, I'm going to again start skipping a little bit around. Otherwise, this video is going to be really long. Here, make sure that you have it in standard form. So we have 8n to the 4th minus 6n cubed. So 4, 3. We're missing a 2. We're missing a 1. We do have a 0. So you're going to have to put in 2 zeros for your missing terms. This one is, again, already given in standard form. And because you do see a number here, it is linear, which is fine, but because of this 8, you have to use long division. So with this long division, I'm going to skip a little bit around, and I'm going to give you the answer as n cubed plus 3 over 8n minus 6. So since, yes, there is a remainder, that fraction, that means no, 8n minus 6 is not a factor. But remember, I provide the answers, you provide the work. You must show me the work. If you give me just the answer, I will not give you credit. Moving on to question number 4. This one's asking us if the binomial is a factor or not. So there's two options to do this. Option number 1 is to check if we have a remainder. Now the way to do that, if you use division, long division in this case, you just go ahead and divide, and if you have a remainder, that's fine. Option number 2, you want to solve for your root. And I'm saying possible root because we don't know if it works. And that root is going to come from the factor of 8x minus 10. So we have a binomial. The factor is 8x minus 10. And we're going to set it equal to 0. We're going to solve for x. Now this is an or situation, so don't do both. Choose one method and use that method. Simplify your fractions. We get 5/4. Now I'm putting this in a thinking bubble because this is not our answer. Then after you solve for the possible root, you're going to check if that root gives you a equal 0 in your polynomial. So solve for the possible root, plug in for x in your polynomial, and then you're going to check for an equal 0. If yes, you have a 0 equals, then that means yes, it is a factor. If it's not an equal 0, that means no, it's not a factor. So we're going to open up for our x value. So we have 8. Oh, let's not use that marker. 8 open 5 minus 82 open 4 plus 114 open 3 minus 62 open 2 plus 80 open minus 50. We're going to write in our 5/4. We're going to pick up a calculator and start writing this in. So 8 open 5/4, close it, caret 5. Make sure you guys can see that. Minus 82 open 5/4, caret 4, plus 114 open 5/4, caret 3, minus 62 open 5/4, close square it, plus 80, open 5/4, minus 50. And yes, it does give us a 0. I'm going to write it on this side since I don't have the room. Okay, so is 8x minus 10 a factor? Yes, it is a factor. B is explain how you know it is a factor versus how you know it's not a factor. There's two ways to know. If your root, so the way that we did it, if your root, which is your x value, plugged in equals 0, then yes, it's a factor. Then the other way, the first way, so I'm going to draw an arrow here. This is what we did. Now, if you use division, this could be with long division or synthetic division. No remainder means yes factor. You can write yes a factor, so it's not like factoring, but it is a factor. Okay. Question number 5 is expand using Pascal's triangle. So we haven't seen that in a little while. What you're going to do is you're going to take a look at this exponent. This exponent is going to tell you what row to use in Pascal's triangle. So for us, since we have 6, we're going to be using the 6th row. I'm going to go ahead and expand. So this is row 0, 1, row 2, row 3, row 4, row 5, and row 6. Now the second number that you write in Pascal's triangle, that's the row number. So since I have 6 as my second number here, this is the row that I'm going to take. After you identify the row, you're going to pick up these are going to be your coefficients. So you're going to be 1, 6, 15, 20, 15, 6, and 1. Okay, you're going to open up 2 parentheses. We call them bubbles, 2 bubbles next to each one. Okay, on your first parentheses, working your way down. Okay, working your way down. You're going to start with 6, and you're going to go 6, 5, 4, 3, 2, 1, 0 on the exponents. And then for your second parentheses, you're going to work your way up. So you're going to start here down at the bottom, and you're going to go 6, 5, 4, 3, 2, 1, 0. Your first term is going to be your first parenthesis. So x is our first term. Your second term is your second parenthesis. Now be careful here with this minus. So we're going to write in a negative 2y. Okay. Now that we're here, you're going to kind of expand before you simplify. So what I mean by that is 1 times x to the 6 is just x to the 6 times. Now here, we do need parentheses on 2. with an exponent of 0, and we need a parentheses around y with an exponent of 0. 6 times x to the 5th power is just x to the 5th power, open for y, and then, open negative 2 parentheses, and then exponent of 1, y exponent of 1. Here you must have parentheses. If you don't do parentheses, it will give you an incorrect answer. And if you had multiple things next to x, then we would do the same thing for x, keeping the parentheses. But since x is just by itself, we don't need the parentheses around x. Let me go ahead and make sure I have my exponents correct. So this should be a 4 here, this should be a 2 here. There we go, almost. And I am noticing a little bit of a mistake that I made, so I'm going to go back and change it. I think I'm getting tripped up with my x's and my y's. So 6, 5, 4, 3, 2, 1, 0 on the x's. 0 here, 1 here, so this should be a 2. So fix that, please. 2, 2, 3, 3. This should be a 4. 4, 4, 5, 5, 6, 6. So because we had a negative 2y as our second term, the exponent on 2 and the exponent of y need to match. And we separate them out like this. Okay, equal signs here. Now, when we're doing this, the numbers go with the numbers. The letters go with the letters. So since we have two different letters, we have an X and a Y, those just kind of get written next to each other. But before I do that, I am going to eliminate anything that is a exponent of 0. So these two are gone. This one's gone. And our coefficients of 1 here, we don't need the 1. It doesn't really change anything, so we just absorb it into our multiplication. So in the very first one, I have x to the 6th power left over, nothing to do here. Now for the second one, I have a 6, so I'm going to do 6 on my calculator. My next number is open, -2. Yes, you need parentheses, caret 1. So for my numerics, I get -12. And then what do I have? I have an x to the 5th power, y to the 1st power. Doing the same thing here. The next one, I have 15 times, open, -2, close it, square it. My numerics are 60 positive. I have x to the 4th power, y squared. 20 times open, -2, close it, cube it. I get -160. X cubed, y cubed. 15 times open, -2 to raise to the 4th power, 240. 6 times open, -2, close it, caret 5. That is -192. And then here, very lastly, we just have open -2, close it, caret 6. Now remember, this is not your answer. This is just your work. So in order to write your answer, we do need to write it in standard form. Now standard form with two different variables, you're going to pick the one that's first. So whatever first term they give you here, that's the one that you're going to write in first. So for my answer, let me shift this up a little bit. I get x to the 6th power minus 12x to the 5th power, y to the 1st power, plus 60x to the 4th power, y squared, minus 160x cubed, y cubed, plus 240x squared, y to the 4th power, minus 192x to the 1st power, y to the 5th power, and lastly, plus 64 y to the 6th power. So all of this needs to be placed in a box for your answer. Okay, moving on. For B, it's going to be very similar. I am going to set this up, but I will not be doing this for you. We're going to take a look at the exponent. The exponent is 4. Remember that the exponent means that this is your row number. So you're going to expand this out. For row 4. Okay. For your answer, you should get 256 a to the 4th power minus 256a cubed b plus 96 a squared b squared minus 16a b cubed plus 1b to the 4th power. Double check your answer. Just a reminder, no work, no credit for questions. Moving on here, factoring completely. Let's take a look at what we see. I see 1, 2, 3 terms. We have a trinomial. For a trinomial, we're going to take a look and see if we have a GCF. Now, GCF is always your first step, and we're going to see if there's a letter or a number that we can divide out. 2, 7, and 4. Now, I drew an arrow on 2 because sometimes when you have a leading coefficient of 1, there is no numerical GCF. It's just like an X potentially. But since we do have a 2, it could be a numerical GCF. So we have 2, 7, and 4. 2 and 7 do not get along. X, X, no X, there is no GCF. Then I'm looking at my A value. My A value is not 1. Since my A value is not 1, that means I need to use the rainbow method. So with the rainbow method, you're going to take a cloud, a bubble here, drag that 2 over, and so we have x squared plus 7x minus 14. We're going to factor here. Now the trick here is always taking this middle variable and writing it as your first terms here. Okay, two numbers that multiply to 14 but add up to 7. We got 3 and 4. We need them to multiply to a negative number but add up to a positive number. So let's see if that works. So I'm thinking if they're both positive, oh, and I made a mistake. No, I didn't. Yes, I did. Yes, I did. I'm like, these won't work. And the reason it won't work is because I wrote this round. This should be 4 times 2. I don't know where 14 came from. 4 times 2 is 8. And that's going to be better for us. Because now I can do 8 and 1 multiplied to a negative 8. Sorry about that mistake. So that means we need a positive 8 here and a negative 1. Now again, this doesn't exist. We do need to undo this multiplying of 2 that we did. So we're going to divide by 2, divide by 2. So x plus 4. Bring up the 2 after you simplify. So this needs to be simplified if you can. 2x minus 1. This is linear. This is linear. That's how you know you're done. For this one here, very similar. There will be no GCF on this one. And your factors are going to be 5x minus 2 and x minus 1. Okay, moving on. Again, you have to show me work for credit. This one here, what do we see? I see a quadrinomial. I see 4 terms. We got to check for GCF, a main GCF. I get 25, 50, 4, and 8. So 25 is 5 times 5, 4 is 2 times 2. So that means I don't have any relationship between 4 and 25. I have an x, 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 no x. So in this case, no GCF. Then we're going to try grouping. And I say try because sometimes if it doesn't work, then we need to use the rational root theorem. So I'm going to group the first two together. And I'm going to group the last two together. I do see a relationship between 25 and 50, so I'm going to divide out by 25 here. And I see x, so I'm going to also divide by the x to the fourth power. So when we are dividing these, we are factoring out. That doesn't mean it goes away. That just means we are pulling it out in front. 50 divided by 25, that's just 2. Close it. And let's see what we can do. We can pull out a -4 here, -4. So we have -4 open x squared plus 2. So that means, yes, we can factor by grouping. We know, oh, hold on a second. This should be a plus. And we know this because these are the same. If your leftovers are not the same, that means you have to continue using the rational root theorem. Make sure that you write your leftovers here, the one that I'm doing in yellow, once. So the way to help you remember is just placing a exponent of 1 on there. And then the GCFs you're going to place together as well. So we have 25x to the fourth power minus 4. Now, since we are looking inside, and inside I don't have linears, I have exponents, that means I have to check if I can factor more. This one here is going to be done because I do not have a minus for a quadratic, but I have an exponent of 2. Also, I cannot take a square root of 2. So this one's done. This one, on the other hand, I can take a square root of 25. I can take a square root of 4. And this 4 is divisible by 2. So this is a minus, so a quadratic pattern for a binomial. So we have square root of 25, square root of x to the fourth, square root of 4. So my a value is 5x squared. My b value is 2. Now again, this is just your check for the pattern. You actually have to memorize the pattern. So the pattern here is 5x squared plus 2, 5x squared minus 2. So we need to combine all of our factors, this one and these two, this no longer exists, for our answer. So our answer is going to be 5x squared plus 2, close it, 5x squared minus 2, close it, and x squared plus 2. Now the reason we are not factoring this binomial here is because we can see that we don't have a minus and we can't take the square root of 2 since we have an exponent of 2. Again, exponent of 2 can't take the square root even if we have a minus. So these are our answers. Okay, very similarly here, we have for D. So again, skipping around, saving time. We have our answer as 3x squared minus 2 and x minus 3. You must show work for credit. Moving on here, I see a trinomial. And immediately catching my attention, I see an x, and I see an x. So that means, yes, I can remove out a GCF of x, and specifically an x squared, because that's the smallest amount. But I see a 2 and a 7, so that means I do not have a numerical GCF. So I'm going to divide everything by x squared. Leftovers here, we have x squared as a GCF. 2 subtract x to the fourth minus 7x squared. And we have 30 here. Now, if you take a look at the exponents, I have a 4 and a 2, which means I have a quadratic pattern. And with this quadratic pattern, I can use the traditional methods of either guess and check or rainbow method. Since my A value is not 1, I am going to use rainbow, giving us, and again, I'm focusing here, x to the 4th power minus 7x squared, multiplying the 2 and 30. Guess and check here. Again, the trick to knowing what you're writing in your binomial factors is you're going to take this middle term, and that happens only for your trinomials with a pattern. Next, we're going to guess and check two numbers that multiply to 60, but add up to -7. So we want multiplication to -60, add up to a -7. So here I'm just going to type into the calculator, do some guessing and checking. So I did 60 divided by 2. I'm going to add, subtract these numbers and check if it gives me 7, which it does not. 3, it does not give me 7. 4, does not give me 7. 5, 12 minus 5 does give me 7. So 12, 5. So I need one of them to be positive, one of them to be negative. So since I need to add up to a negative, 12 is negative, 5 is positive. And remember, this doesn't exist. This is just temporary. So since I multiplied by 2, I have to divide by 2. You must simplify your fractions if you can. So we have 12 divided by 2, that's 6. And here we have 2x squared plus 5. And then we check if we can factor more. So I'm going to do a little thinking bubble. So I'm going to check here. I have a exponent of 2, which means it is even, which means we're looking for a quadratic pattern for a binomial, okay, difference of squares. But I'm also noticing that I have a 6, which I cannot take a square root of. This is done. Here, same thing. Immediately this fails for a difference of squares because there's an addition symbol. So this one's done as well. Now this is not your answer because we did have a GCF. So combining with our GCF for our answer, we got x squared, open, x squared minus 6, close it, 2x squared plus 5. Okay, moving on. For F, we're doing that similarly. Make sure you factor your factors on this one. So our answer is going to be x squared, open, x minus 2, x plus 2, 5x squared plus 4. You must show work for credit. Double check your answers on this one. For this one here, this one always gives us a little bit of trouble because of it being able to be a even pattern and an odd pattern. So it could be some difference of cubes, but it also could be a difference of squares. So when we want to use the difference of squares. So that means I'm going to take a square root of both. And the reason we can do that is because we see a minus. So that means my A value is going to be x, divide that by 2, cubed. And the square root of 64 is 8. That means we have x cubed plus 8, x cubed minus 8, which gives us 2 cubic binomials with patterns. I'm going to write it out here just because of space. So my first one, we can take the cube root of x cubed, take the cube root of 8, so I get a new a of x and a new a of 2. With our pattern, we got a, b, a squared, a, b, and then b squared. Now for our symbols, it's always same, always different, always positive. Now we're going to do the same thing for our other cubic pattern. Notice that our A's and B's are going to be the same. The difference is going to be with the signs. So again, A, B, a, ab, and then b squared. So our signs on this one is going to be always same, always different, always positive. Let's go ahead and simplify this out. So x plus 2, x squared minus 2x plus 4, x minus 2, x squared plus 2x plus 4. These ones here, these binomials, could potentially factor further if they are of higher power, but these trinomials are always going to be done. Note original GCF, we had a leading coefficient of 1. Right? For H, it's going to be similar. Again, be careful with your factoring of factors. We do have a GCF here that I can see x and x. So we have x open 2x minus 1, 4x squared plus 2x plus 1, and 2x plus 1 times 4x squared minus 2x plus 1. You must show work for credit. Please do not just copy down answers. Graphing. Question number 7 is asking you to graph the following polynomials. Now this one is already given to you in factored form. How do you know it's in factored form? You see factors. This is given factored form. And you can think bubbles on this one. So if you see groupings, if you see parentheses, if you see these bubbles, that means it's in factored form. Step number 1, in factored form, you're going to write in any missing exponents on your variables. So I have a missing exponent on my factor of x minus 4. I have a missing exponent on my variable of x. Total degree is in factored form, adding your exponents up. 2, 3, 4. Now again, we don't care that it's 4. What we care about is if it's even odd. So I'm going to close this. This is even. Next, I'm going to take a look at my leading coefficient. And my leading coefficient is 3/4. And again, I'm going to cross that out because I don't care that it's 3/4. What we care is if it's positive or negative. Combined, this is going to give you your end behavior. For an even function, the end behaviors are going to be same. So you're thinking the left hand and the right hand side are going to be same. For a positive, we're thinking increasing. So a shorthand, here's your left, here's your right hand side. Since we are the same on our left, right side, and we're increasing, on the left hand side we're going up, on the right hand side we're going up. So the official way to do the end behavior is as we are going to the right, this is positive infinity, and as we are going to the left, negative infinity. So on the right, we're looking at our shorthand. We're going up to positive infinity. On the left, we're looking at our shorthand. We know this is left because it's negative infinity on the x. On the left, we're going also up. So for your x values that we have here, this is what we're talking about. That's how we know if it's the left or the right-hand side. Next, we are going to identify our roots, our zeros, our x-intercepts. And so we can do that. I can rewrite it here. So we have 3/4. We don't really care about 3/4. X to the first power, x minus 4 to the first power, and then x plus 3 squared. I'm going to set each value, each factor equal to 0. And then we're going to solve. Now, you don't really care about the exponents in this step. You're just finding your x values. So here x is 0, here x is going to be 4, and here x is going to be negative 3. Then we're going to take a look at the exponent, and the exponent is going to tell us the behavior at each 0. So this is going to be linear, align. This is going to be linear, align. This is going to be even. So it's going to be kind of like a parabola. We're not going to go through the x axis, we're going to just give it a quick little kiss and then turn around and go back up. Okay, so here's your graph. You're going to start with identifying your roots, your zeros. So here's 0, here's 4, and here's -3. Do not mark any other spots on the x-axis. You are unable to touch or cross anywhere else on the x-axis except your zeros. Next, you're going to draw out your end behavior. So here's my left side. Here's my left point. I'm going to be going up. Here's my right side. Here's my right point. I'm going to be going up. Okay, these are just reference. I am using a pencil on purpose. So as I approach 3, negative, we're going to have an even behavior. So I'm going to move this a little over. I'm going to go down to -3, but I'm not going to go through it. I'm going to go up. Quick little bend because I have to make connection with 0. 0, we have a line, so I'm going to go straight through with a little slope. No bends here. Again, quick turnaround to 4, which I also have a line. I'm going to go through 4. And as you can see, I do need to make some corrections. So I'm going to move that dot here and then point up. So the way we're grading these, we're taking a look at your end behavior. So end behavior are these. They have to be pointing in the correct location. I'm going to be taking a look at your zeros, which are your dots. And I'm going to be taking a look at your behavior at each 0. So what are your multiplicities, your exponents, and what is the behavior at each 0? So that's what we're grading. Find the y-intercept. We haven't done this in a little while, so let's go ahead and recall what that means. Finding the y-intercept, it means make x equal to 0, solve. So all you're doing is you're going to open this up. You're going to plug in 0 anywhere you see x. You're going to pick up a calculator and you're going to type this in. The one way that this could give you a wrong answer is if you don't put parentheses around your fraction. Come on. So open 3 over 4, close it, 0. 0 minus 4, 0 plus 3, square it, and we get 0 as our answer. We can also see here that this is our y-intercept. Now this one's going to be pretty much identical with one exception. Notice that there are no parentheses. So this means it's not factored. That means you must factor. So we're taking a look at what we have. Okay, well, what do we have? I see an x, 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 so we're going to remove an x. I see a trinomial with a leading coefficient of 1, so we're going to use guess and check. Next, we're going to find two numbers that multiply to a -6, add up to a -1. So we have -3 and a +2. So here is now your factored form that we're going to graph. So that means I'm going to have a root at 0, a root at +3, and a root at -2. These are all linears. I have an exponent here, here, here that's missing of 1. And again, how do we know the behavior at each 0? Well, we take a look at the exponent on the outside of the parentheses. For total degree, you have two options. If you are looking here on your factors, you can add them up. Or in expanded form, in the not factored form, we can just have your total degree, which is the highest exponent. So total degree we have is 3, which is odd. Leading coefficient we have is 1, which is positive. I was going to write increasing, but that's okay. Increasing, positive. Odd means your left hand side and your right hand side are going to be different. Positive means increasing. So shorthand for our end behavior. Left-hand side, right-hand side. So a trick here, and I'm going to do this kind of off to the side because it doesn't have anything really to do with graphing or polynomials, it's just a trick. For an odd function, you can draw a quick cubic and see which one is increasing and which one is decreasing. So we don't want the decreasing one, we want the increasing one. And then you see what's happening on your left-hand side and your right-hand side for your behaviors. You can see that your left-hand side is going down and your right-hand side is going up, which means here's x going to infinity. That means you're going to the right. X is approaching negative infinity. Means we're going to the left. So on the right-hand side, we're going up to positive infinity. On the left-hand side, we're going down to negative infinity. Okay, let's go ahead and graph. First thing you're going to do is find your roots, your zeros, your intercepts. Don't mark anywhere else. These are the only places that you are able to touch or cross your x-axis. Behaviors, on the left-hand side, here's my left-hand point. I'm going to draw an arrow down. On my right-hand side, my right point, I'm going to draw an arrow up. We are increasing, we are on. Okay, as I approach -2, we do have a linear behavior. So I'm going to have this as a line. Quick turnaround at 0, we have another line. Quick turnaround, and then at 3, we have another line. So again, what are we grading? We're grading the behaviors at each 0 that you have. We are grading your end behavior, and we are grading your roots, your zeros, your x-intercepts. Now again, for your y-intercept, and this doesn't always happen to be like 0, 0 as before, but what you're going to do is you're going to set x equal to 0, solve. So we have, you can use the original. Easier to use the original. Open up for your x value. And what you'll see is 0 minus 0 minus 0 is still 0. But again, don't expect this always to be 0. Sometimes it is, sometimes it's not. Okay, moving on. This one here is graphing cubic functions. So this is a little bit different than graphing their polynomials in that there is a pattern that we can use to graph. And this is in a particular format where we have our h's and k's. H is always opposite of what we see. So we can have our point of inflection as +4, +2. With our point of inflection, the next thing we're going to do is we're going to create a t-chart. This point of inflection, we're going to write in the center, and we're going to choose some pretty points going up and down on the t-chart. Now, you have to make sure these points are pretty points, meaning points that we can graph. Things like 3.875 is not something we can graph. Okay, what you're going to do is you're going to type into the calculator parentheses 1/3, make sure it's in parentheses, open your x value minus 3. You're going to type in a caret 3 for your exponent and then +2. So open 1/3, close it, open. I'm going to use 3 minus 4, close it, caret 3 +2. So something like this is not pretty, so I cannot use 3 as a point. I'm going to go up, go over, make this 3 into a 2. Nope, can't use 2 either. 1, yes. So I'm going to actually, just for space, I'm going to erase these. So the number that I can use is 1 because it gives me a pretty number of -7. So I'm going to go back. Now I'm going to try 5. Nope. 6. Nope. 7. Yes. So again, can't use 5, can't use 6, but I can use 7, and that gives us 11. To graph, you're going to start with this point of inflection. We have 4, we have 2. Identify it, either I or P or something. Don't lose this point. Then we have 1 and -7. and we have 7 and 11. Now the trick here is if you were to line these up, they should give you a straight line. So for example, this one needs it to be a little bit higher. But you're not actually graphing a line. This is going to be your John Travolta behavior. This is going to be your odd behavior, your cubic behavior. Your point of inflection, you're going to put your pencil, you're going to bend and then go down. And then we're going to bend and go up. Now I am a little bit off on my point here, so I'm just going to move it. Make sure you have full connection with your point. Now somewhere here you do have an x-intercept. Where that happens, we're not really sure. We didn't check, right? We didn't solve for that. So I am okay if you were to remove these and only give me the actual values that we need. So for example, this one was 4, this one was 7, this one was 1. If we knew what the x-intercept was, then we could actually like know exactly where it is, but we haven't solved that. Now let's just move on. I was going to say something, but it's okay. All right, for domain. Domain for your cubic function is always going to be the same. It's going to be from negative infinity to positive infinity. And your range is also going to be from negative infinity to positive infinity. There are no limitations on your cubic function, so you can just write, it's going to be all real numbers as well. Now, for your y-intercept, remember, y-intercept is when we make x equals 0. So for your x value, you're going to write 0. That means we're going to open up our function here, just like we did before. But this time, I'm going to input 0 and see what my output is. Now, decimals are not allowed. Please do not put decimals. So the way you're going to do this is you're going to press second, press PRB, enter. Now this is going to give you a mixed number of negative 19 and 1/3, which means that we need to convert this to an improper fraction. So this negative we're going to ignore. We're going to keep the denominator of 3. We're going to multiply and add. So 3 times 19 plus 1. 3 times 19 plus 1. So we get 58 over 3 as our y-intercept. Okay. The only difference with what we did in A versus B is that notice that there is a, no pun intended, B value. So we need to factor that out. We get negative 8, open, 1/2, open. And then in order to do that, we're going to divide this 2 by that 1/2. So 2 divided by open, 1/2, and I get 4. Negative 4. And then we proceed as usual. Here's your H value, opposite of what we see. Here's your K value for keep. So we have our point of inflection here at positive 4 and positive 1. I'm going to go ahead and skip this one. It is going to be similar to that of 8. Please make sure you do this on your own and then check your answers during class time. All right, beautiful people, that is it for part 1. I will create another video for part 2. Enjoy the rest of your day.